Hey guys, welcome to our next flipped video lesson. Today we'll be simplifying expressions using the rules of our order of operations. Now, order of operations is something you've probably heard before, and it's most often been probably framed to you as an acronym called PEMDAS. And PEMDAS is supposed to help you remember the order of operations. But we have a problem. You see, PEMDAS can be very deceiving. The reason PEMDAS can be very deceiving is because your dear Aunt Sally, right, please excuse my dear Aunt Sally, is probably a sentence you've heard to help remember PEMDAS, is not your dear aunt. She's really a zombie who wants to eat your brains. You see, PEMDAS will lie to you. PEMDAS will want you to believe that addition comes before subtraction and that multiplication always comes before division because it's listed in that order. But that's a lie. Multiplication does not always come before division. Division can come first, and subtraction can come before addition. An acronym we like better, which will help us more accurately use our order of operations, is GEMMA. Now, GEMMA is grouping symbols, which we'll talk about in just a second, exponents, multiplication or division, and addition or subtraction. Notice the big difference here is that multiplication and division are on the same level. Addition and subtraction are on the same level. Well, let's talk about grouping symbols. We don't just have parentheses anymore. We actually have 5 different grouping symbols that we have to be aware of and know how to work with. We have parentheses, brackets, and braces. Now, those are pretty much the exact same grouping symbol. They're just shaped differently, so it's easier to identify them in the expression. But absolute value bars and our fraction bar are grouping symbols we'll talk a little bit more about later that do have some extra pieces to them. Well, how do we know what comes first if multiplication and division and addition and subtraction are on equal levels? Well, we read from left to right, so we use that direction to decide which comes first. If we look at an expression and read from left to right and multiplication comes first, we do multiplication first. If division is first, we do division. Same with addition and subtraction. And we'll see that in a number of our examples here coming up. But before we can get to that, we do need to talk about the absolute value bars, these grouping symbols. They're a special type of grouping symbol that have a special power that parentheses, brackets, and braces don't have. Think of the absolute value bars as kind of like the X-Men, the mutants of the grouping symbols world. They're not just normal humans, they're humans with special powers. Well, the absolute value bars are a distance a number is from 0, right? It's a distance, and that's an important quality here. We can see if you started at 0 and you walked to the number 3, you would travel 3 units on the number line. If you started at 0 and walked to -7, you would travel 7 units on the number line. Now, one thing we notice about the distance here is that distance is never negative. You can't run a negative mile. You can't drive your car a distance of negative miles. You can run backwards. You can drive your car in reverse. The direction can change, but distance is always going to end up being positive. Well, since absolute value is a distance, and distance is always positive, that means when we simplify something using the absolute value operation, it's always going to come out positive because we're finding a distance here. So let's take a look at an example here. So we have the absolute value of 6 minus 14 plus 2. Now, these are grouping symbols, so we have to simplify everything inside first. Now we have a subtraction and addition inside our grouping symbols. Which comes first? Well, let's read from left to right. Subtraction comes first, so we subtract first. We get -8. Then I add, I get -6. Now I am ready. I've simplified inside the grouping symbols. Now I'm ready to simplify the absolute value of -6, which is +6, because the distance from 0 to -6 is 6 units. Again, notice, I simplified everything inside the absolute value bars before I used the absolute value operation to find the distance from 0 to -6, and that's going to be important. Okay, so now we're ready to try some examples together here. So let's take a look. The first example has 3 operations, subtraction, multiplication, and addition. If we follow GEMMA, multiplication comes first. Then we know subtraction and addition are equals. We read from left to right. Subtraction comes first, -3, and then we add 2. Let's look at our second example. Now I've got division, exponents, multiplication, and subtraction. Well, exponents comes first, so that's where I get the 9 from. Then I have division and multiplication. Well, which comes first? They're equal, so let's read from left to right, and we can see that the division comes before the multiplication. 45 divided by 9, 5 times 5, and then we subtract. In our third example here, we can see that we have grouping symbols inside grouping symbols. we always have to work from inside out. So the first grouping symbols I deal with are parentheses, so I do 30 divided by 6. That gets me 5. Then I have to work inside my absolute value bars. Well, 5 squared, exponents come before addition, so it gives me 25. Then 5 plus 25 gives me 30 inside my absolute value bars. Well, what's the absolute value of 30? It's 30. That's how far away it is from 0. Last, I have the multiplication, which was outside those absolute value bars, and we do 2 times 30 is 60. The last we deal with are fraction bars here. Now we can see that we have stuff on the top and we have stuff on the bottom of our fraction bars that needs to be simplified. And what the fraction bar does is it separates the top and the bottom. We have to simplify everything in the top and then everything in the bottom, and then we can actually do the division of the fraction bar there. Okay, so first you can see I dealt with my exponents. Now notice one important thing here is that our exponent is only on the 5, not including the negative. So that's why when I square it, I'm only squaring the 5, not the negative, and that gives me negative 25 minus 7. Negative 25 minus 7 is negative 32, and I've simplified the top. 7 plus 2 is 9, and I've simplified the bottom, and that's as simple as we can make that fraction. Negative 32 over 9 does not simplify any further. We can just leave it as a simplified improper fraction. Well, we've tried 4 together here, so now I want you to try 4 on your own. So go ahead, pause the video, and fully simplify these expressions. And please, 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 guys, if you want credit in class, show your work. Ready? Pause. Well, let's see how you did. Hopefully, you got 14, 18, 0, and negative 5 over 2. If you did not get these answers, guys, please, please, please ask in class. We'll go over them. We'll work our way through them and make sure we're really understanding how to use GEMMA in these order of operations here to simplify our expressions. Well, that brings us to the end. And, you know, if you love zombies or you love plants, I guess this could be the way the world ends for you. Until next time, we'll see you later.